Hi, everybody. It's Miss Rose. This is week 36, lesson 2. And you know what that means. This is the last video lesson of our 2020-2021 school year. So we have made it. And this one's really just going to be an extension of week 36, lesson 1 that you just saw from Mr. Millington. So what you should have learned from that video is there's a basic formula that we use for the equation of a circle, which is x minus h squared plus y minus k squared equals r squared. What you'll notice is when there's an equation that's a circle, the x and the y are both squared. So that's how I can look at this one and know that it is a circle. And the h and the k stand for the center of the circle. And then the r, of course, is the radius of the circle. So let's take a look at an equation for an example. And then this is just like we did in lesson 1. I added this little extension of can you find the area? So let's start with the center. We have x minus, and then 9 is the x coordinate. And then y, this is kind of weird. There's y, and then there's nothing added or subtracted or anything from it. So that actually just means that the y coordinate is 0. And then how do we find the radius? Well, this number over here is radius squared, so I can just square root the 36. And that's 6. So the only part that I added to this problem is find the area. There's a circle, so of course we're going to go RDCA. So radius is 6. You double it to get the diameter. You put a pi on the diameter, that's the circumference, and then radius squared pi. 36 pi, 36. That number looks so familiar. Where have I seen 36 before? Right, that was in the equation. Radius squared is already in the equation. So let's save ourselves a step. As much as we love the whole RDCA thing, I can actually jump right to the area because I already know what the radius squared is. So all I have to do is throw a pi on it. So look for that to come up in the homework. Don't waste your time square rooting it and then squaring it again. If we know the radius squared, then we know radius squared pi for the area. All right, let's try that for example 2. Center, be really careful. This says x plus 5. We want for our circle equation, we want x minus the x coordinate. So if it's x plus 5, that actually means that the x coordinate's negative 5. For the y's, though, it says y minus 1, so the y coordinate's going to be positive 1. The radius, well, for the radius, we can just square root this constant over here. Square root of 29. That sounds messy. I'm just going to leave it as root 29. And then can we do the area without doing the whole RDCA thing? Sure we can. We know radius squared, so all we have to do is put a pi on it. This one's an example where if you tried to find the radius, root 29 is a messy decimal, and then you probably would round it, and then when you'd square it to find the area, you'd actually have a little bit of error. So it is much better to just jump straight from the equation to the area. All right, let's see what we have next. This time we are writing an equation for a circle. So I kind of like to just set up my formula and then plug the numbers in. So we've got the center of the circle is -7. I don't really love writing it like that because that looks messy, x minus -7. So I like changing it. If it's -7, I like to write x plus 7 squared. And then same thing with the -11. Instead of writing -11, I like to write y plus 11 squared. And then remember what we just talked about with the area. If it's 95 pi, then the 95 is the radius squared, and I can just steal that and put it right in my equation. So that right there is the equation of our circle. All right, how do we graph a circle if we're given an equation? Well, I do the same thing that we did above. I find the center and I find the radius before I even go to the graph. So I find if I have all the details down, then I can make a pretty good sketch. So x minus 7, so positive 7. This one, though, be careful, y plus 6, so it's going to be -6. And then also be careful with the radius. It's not 4. Remember that 4 is the radius squared, so you have to square root the 4, which is 2. It is harder than it seems like it would be to draw a good circle. So I'm going to plot the point 7, -6. It's my center. It's not a point on my circle, but it's a point at the center of the circle. Then what I'm going to do is I'm going to go 2 units in every direction because that's the radius. So I go up 2, make a point. I go down 2, make a point. I go right 2, plot a point, and left 2, plot a point. And then it's kind of hard to draw this in a nice rounded way. Don't make a diamond. Try your best, make a circle. The bigger the radius is, the harder it is to draw a nice circle, actually. So there is a decent sketch of our circle graph. It's not going to be perfect. Just try your best to draw something that resembles a circle. And then the follow-up question is, does the point 6, -4 lie on the circle? Gosh, that's really hard to tell. It might. It comes close to the circle. Here's what I'm going to do because I can't really tell from the graph all that well. So I'm going to use the equation. If you plug in 6 for x and -4 for y, then you can tell if the point lies on the graph or not. So I'm going to go 6 minus 7 squared plus -4 plus 6 squared equals 4. So all I did was I just plugged in the 6 in place of x, and I plugged in the -4 in place of y. And 6 minus 7 is -1 squared. And then -4 plus 6 is 2 squared. Does -1 squared plus 2 squared equal 4? No, it doesn't. -1 squared is 1. 1 plus 4 does not equal 5. No. So the point's close to the circle, but I think it's just a little bit outside the circle. So that's how you can tell. If you can't tell by the graph, then use the equation, plug the point in, and see if it satisfies the equation or not. All right, I have one last example for you. This is it. We've come to the end. The last example. There is a circle graphed, and it says write an equation for the circle. So what is the center of the circle? I do the same thing as all the other problems. I ask myself for the information first before I try to write an equation for it. There's the center. There's a nice dot on it. -1, 3. What's the radius? Well, I count in any direction, right, left, up, or down from the center. 1, 2, 3, 4 boxes. Radius is 4. That's the information that I need to know to write an equation. So now I can plug it right into my formula. X minus -1, so I'm going to write it as x plus 1. Don't forget to square it. If you forget to square it, it won't be a circle. Y minus +3 squared equals, and then make sure that you square the radius. 4 squared is 16, and that's the equation of my circle. And then I can always go to Desmos.com and graph it in the graphing calculator to make sure that it looks like this one. So that's a good check, just to make sure. And that's the end, everybody. Circle equations are the last thing that we're going to learn about this year. So thanks for listening. Thanks for learning with us. I have a couple other videos I'm going to post just of content that might be useful for you to know moving on to later math classes that there won't be any homework or quizzes or anything for, but that might be useful. And yeah, thanks for watching, and I've enjoyed learning with you all this year. Bye.